Hi guys, it's your favorite teacher Kaumaji Mwanza, and welcome to Learning Science the Easy Way. So for those that are watching me for the first time, on this platform, I teach sciences, physics, and chemistry. So I encourage you to subscribe to my YouTube channel so that you'll be able to receive a notification whenever a new video is posted. Video, I'm going to talk about the moment of force, the principle of moments, and the calculations involving the moment of force. When turning something, a force is involved and pivot. But you will turn it more easily if you apply a force further from the pivot. So the physical description of this is what we are calling as the moment of force. So moment of force is the product of force and distance perpendicular to the line of action from the pivot. So what it means is that if you have a metal bar, then you suspend 40 newtons, then the distance from here up to the pivot is 2 meters. So this is our pivot here. So the moment of force for this is going to be moment is equal to force times the distance. So this is the distance from here up to where the force has been suspended. Then we have our force, which is 40 newtons. So we'll say 40 newtons times 2 meters. You are going to have 80 newton meters. So that will be our moment of force. Now, in the same scenario, if again you are given another force, for instance, you suspend another force this side, we say 80 newtons. So meaning the distance from here to here, we'll put it as 1 meter. So when you multiply this one and this one, you are going to have 80 newton meters. So what this simply means is that the moment of force on both sides is equal. It simply shows that this particular bar is in what we are calling as equilibrium. So meaning the clockwise moment is equal to the anticlockwise moment. Therefore, the principle of moments states that for a body in equilibrium, the sum of the clockwise moment is equal to the sum of the anticlockwise moment. So according to the principle of moments, we are saying for a body in equilibrium, the sum of the clockwise moment is equal to the sum of the anticlockwise moment. So here we are saying the clockwise moment is equal to the sum of the anticlockwise moment. So that is basically according to the principle of moments, or that is what the principle of moment states. Okay, so let's look at this example. A ruler is pivoted off the center but kept in equilibrium by the suspended mass of 240. So this is a ruler which we have, and in this case this ruler is pivoted at 20 centimeters and the mass of 240 is suspended at 5 centimeters mark. Then again we are saying the center of mass of the ruler is at 50 centimeters mark. What is the mass of the ruler? That is the question. What is the mass of the ruler? After we've been given all these details, what is the mass of the ruler? And mind you, this ruler is already in equilibrium. The ruler is already in equilibrium. This is the key word here. It simply tells us that the moment produced by this 240 grams is equal to the moment produced by the mass of the ruler. In order for us to calculate the mass of the ruler, we are going to say this mass suspended is going to be our M2. Then this distance from here up to 20 will be our distance 2. Then this distance from here up to 50 is going to be our distance 1. Then the mass of the ruler, we write it somewhere, that is going to be our M1. So according to the principle of moments, we are saying the sum of the clockwise moment is equal to the sum of the anticlockwise moment. So like in this case, we are going to say M1 times distance 1 is equal to M2 times distance 2. So our M1 here is the mass of the ruler, which is M, times distance 1. So distance 1 is the distance from the center of mass of the ruler to the pivot. So in short, we are saying 50 minus 20, we close the brackets, which is equal to M2, that is the 240 grams, which is given, times the distance, which is 20 minus 5. So we are going to say M1 times 50 minus 20, which is 30 centimeters, equals 240 grams times 20 minus 5, which is 15 centimeters. So here we are going to have 30 centimeters, and the M1, which is the mass of the ruler. Then when we multiply 240 times 15, you are going to have 3,600 grams centimeters. Then you divide both sides with 30 centimeters, and this side 30 centimeters. So you cancel there. You're going to have M1 there, which is equal to, then you cancel the units, then 30 into 3,600, you are going to have 120 grams. So the 120 grams calculated is the mass of the ruler. So basically, this is a very important concept in physics, and I hope you followed through. Thank you very much for watching.